Hi guys, today we're going to work on exponents. And the I can statement we're working towards is I can simplify exponential expressions using the properties of exponents. So if I wanted to think of multiplication, it's a quick way to write addition problems where you're adding the same numbers repeatedly. So, for example, if I wanted to add 5 6 times, I could add 5 plus 5 plus 5, or I could simply say 5 times 6. Well, using exponents is a quick way to write multiplication problems where you're multiplying the same number repeatedly. So if I wanted to multiply 5 6 times, I can write that as an exponent and say 5 to the 6th power. An exponential expression has a base and an exponent. This 5 is the base. The base tells you what number to write down or to repeatedly multiply. This 6 is an example of an exponent. And an exponent tells you how many times to write down the base or repeat that base in the multiplication problem. So every exponential expression has a base and an exponent. In this case, the base is 5 with an exponent of 6. So I would write out 5 times 5 6 times. When I write it out, that's called expanded form. That's simply taking your exponent and writing it as a multiplication where you repeat the base, the number of times stated in the exponent. If you were to work it out and multiply 5 6 times and get an answer, that is called standard form. Let's take a look at some exponents in base 10. Well, I'm going to skip 10 to the 0 because I really don't know much about that yet. But let's look on to 10 to the first power. 10 to the first power means I'm repeating 10 one time. Well, if I have 110 in standard form, that's going to be 10. 10 to the second power means 10 times 10. And everyone knows 10 times 10 is 100. 10 to the third power is 10 times 10 times 10. Well, 10 times 10 is 100 times another 10, that gives me 1,000. If you'll notice, every time I raise 10 to a new power, I am simply adding on 1 0 or putting the same number of zeros after the 1 as indicated by my exponent. So 10 to the fourth power would be a 1 with 4 zeros, or 10,000. 10 to the fifth power, which is 10 times 10 times 10 times 10 times 10, is going to be 1 with 5 zeros, or 100,000. So let's work this backwards. If I wanted to start here at 100,000 and take away one of those 10s that I multiplied, or divide by one of those 10s that I used to multiply, I would get 10 to the fourth power and 10,000. If I went up and took away another power of 10, so changed it from 10 to the fourth power to 10 to the third power, that'd be like dividing 10,000 by 10 to give you 1,000. So each time I'm taking away a 0, every time I divide by another 10 to move up the table versus down. So if I'm using that process, what would 10 to the 0 power be? You guessed it, I would have to take away another 0, which would leave me with just 1. Any base, when raised to the 0 power, is always going to equal 1. So let's look at some examples. 1 to the 0 power equals 1. 2 to the 0 power equals 1. 3 to the 0 power equals 1. 4 to the 0 power equals, you guessed it, 1. 5 to the 0 power equals 1. 6 to the 0 power equals 1. 7 to the 0 power equals 1. Any base to the 0 power is going to equal 1. Now it's your turn. Complete the table below in the work section of your WSQ. You can pause the video now and complete this table. We are done with the video. You can go back and watch any portion of the video or the entire video as many times as you need to. And don't forget to WSQ in your notes.